Thank you for the gentle introduction, and thanks for having me. And what I'm going to present now is server-side rendering. So fasten your seatbelts and get excited for just another exciting topic. Before we start, I'd just like to introduce myself. My name is Ferdinand, and I'm mainly into, as Yuri said, I'm into Angular, Node.js, and TypeScript. And by the way, I'm from Leipzig, Germany. So it literally just takes me 4 hours to get here. However, we were stuck in Warsaw, so it took us like 30 hours, but that was okay. So I'm glad to be here. And it's been a great time so far here at NgTalks, so great that you are here, and it's great that I can be here. By the way, I'm one of the authors of the German Angular book, and also I'm the co-founder of Angular Schule, which translates to Angular School, and we're doing on-site workshops and training and consulting all around Angular. Okay, so let's start. You all develop Angular applications. We all develop Angular applications, and what we usually do with Angular is we're developing single-page applications that run in a browser. And the spirit of a single-page application is that it consists of an empty HTML page. It's like just a skeleton, and the actual contents come in via JavaScript. So those are the application bundles that have been built with Webpack, and that is the part that actually does our contents in the page. So now I actually have brought an Angular application. It already runs here, and we have it here in the browser. So it's like a very simple thing. You have a list of items, and you can go to a detailed page and view everything. So it's like a fully featured Angular application, let's say it like that. So now I'm doing something unusual. What I do is I switch off JavaScript in the browser. And what happens is we just see a blank page down. So you might actually ask now, who on earth is switching off JavaScript in 2018, right? That's a really fair question. So I can tell you who does that. Search engines. Right, here you go. The Googlebot doesn't really like to render JavaScript. That is not 100% accurate at all, so the Googlebot does actually render JavaScript, but however, they don't really like to wait for JavaScript being rendered. So it doesn't really matter how highly optimized our content is, what great blog articles we write. As long as the search engines can't see us, of course, the people won't find us, and that is bad. What is more, when we take a look at our JavaScript bundles, they are like 3 megabytes of size. Of course, that is not optimized, that is just JIT compiling, but however, our Angular application takes a few seconds to load until the bundles have been downloaded, until everything has been rendered and stuff. And the time to the first meaningful paint can be very, very long. And I tested that with a really bad mobile reception and with our simple app, and it took us like, you might guess, 2.7 seconds. And that's not acceptable. There is some research that proves that people tend to leave a page when it takes more than 3 seconds to load. So that's definitely not what we want. Okay, who else is visiting our page? Right, Twitter and Facebook. Twitter and Facebook tend to generate site previews of all the great blog articles we post, but when there's no content on the page that the bots can see, of course, there's no need site preview to preview. Damn. So we actually need a solution towards that problem, and I think there are 2 solutions. First is, don't do single-page applications. Yeah, but you know this is nonsense because we want to do single-page applications. So the second is, what about not leaving this part empty? So during the time where the Angular application bundles haven't been loaded yet, the user should just see something that almost looks like our page. And that's what I want to do with you today. I want to introduce you to 3 strategies of doing that. The first is taking a real browser and doing some pre-rendering. The second is dynamic server-side rendering with all the Angular stuff. And the third is a bit more advanced, which is static pre-rendering, which you do at build time. So let's dive in there. Pre-rendering with a real browser. This idea is very naive when you think about it, because you just take a browser, open the page, wait for it being rendered, and then you just take the DOM tree and save it as HTML to your file system. It's easy as that. So that's the closest thing you could think of. And because we don't want to do everything of that for ourselves and manually, there's services that do that for us, and one of them is prerender.io. So what prerender.io does is, it provides a middleware for our web server. So whenever a user requests our page, they get to the middleware, and the middleware decides, is this a bot or not? Well, and then, if it's a bot, the request is being redirected to the prerender.io service. And what they do is, they just open our page with the browser, get back the application bundles, and then, this is the important part, they send back the HTML from the browser to the middleware, and with that, back to the client. So the client doesn't really take notice of that there's a pre-rendering thing between that. They just see the generated page just like another browser saw it. That's the thing. However, when you take a look at that, it looks really complicated. So there's so many errors in here and so many entities that work together. There must be a simpler solution. The good part of that is that it works with every page. So no matter whether you use Angular, React, or Vue.js, I heard some people even use jQuery, but we don't talk about that. It works with every page as long as it's working in a browser. So that's a good part. However, let's talk about another idea. It would be a good thing if Angular and our infrastructure would care about not just delivering an empty HTML page, but pre-rendering all the content for us. And that's where we talk about server-side rendering. The idea behind this is, whenever a user requests our page, the server boots up the Angular application right on the server without a browser, and then send back the resulting HTML to the client. And then later on, the Angular application bundles are being downloaded, and Angular takes over the page, and it works as usual. That's the spirit of server-side rendering. Angular 2 and above have been built from the ground up to support not only the browser, but literally like every platform that runs JavaScript. We saw it yesterday in the talk about native script, that we can run Angular not only in the browser, but also on mobile phones natively. And there are examples that run Angular on IoT devices. And of course, we can also run Angular on a server. That's what we need here. To run Angular on a server, we can use a project called Angular Universal. And that resides in the package at Angular Platform Server. And they have everything within there to run, just run Angular on a server with Node.js. So let's take a closer look at what our application looks at the moment. Right? We have got that simple application, and of course that has an app module, which is the central module, and every application has a central module. And within there, all our components span up like a tree. What the app module also does, it imports the browser module from Angular. And what is more, we've got a main.ts file which bootstraps that whole app module and works as the entry point for the Webpack build. So as you can see it here, this is a standard Angular application. What we do now is we wrap that whole application into another module, which we call App Server Module. And that App Server Module imports the native server module from Angular. And then we wrap all of that into another TS file, which is a second entry point for the server build. So now we've got two entry points for two different build tasks, right? We've got one build for the browser and one build for the server. While all this looks very complicated, of course, there is a way of doing this very easily, and that is schematics. Of course, there is a schematic built into the Angular CLI to just generate all that stuff for us, and that's what we're going to want to do now, and that is NgGenerate Universal. It's easy as that. And we just do this. I kill the ngserve, and I do NgGenerate Universal. We need to provide the client project, like the name of the client project, as a parameter. And then some files are being created and updated for us. And now let's take a look at what has been generated. At first, there's that app server module. So that imports the app module and the server module, as I told you earlier. Then there's the main server TS, which just imports and exports the app server module, so the Webpack build for the server can just take it and do something with it. Then we have an additional section in the angular.json. That is the part that tells the Angular CLI that here's a task to do to build the server. It's being generated automatically, and it's very easy to do. And another very important part is that one. Instead of importing just the browser module, we instead import the browser module with server transition. This makes sure that the client-side Angular application can take over the server-rendered Angular application later on and just takes its state with it and so on. So that's the Angular application, and it's all prepared for server-side rendering now. What we need to do is we need to build our application. Once for the server and once for the client. And those two commands are like that. NgRun, then the name of your project and the target server. I just run it here. And the second one might be already known to you. That is just the client-side build, ngbuild --prod. Okay, and after we did that, we've got two new folders under our dist directory. One is for the server, and one is for the client. So this is two different separated build artifacts. Now that we have all the bundles prepared for us, we need to build a server around it, because just by existing, those bundles don't do anything, right? So we need to set up a server. And the server has two main duties, which is, first, it needs to pre-render our application and deliver the resulting HTML whenever a user requests the page. And the second is, it has to function as a simple web server, so it just delivers all the application bundles and all our assets statically. So that's a very simple task. The first one is interesting. So when talking about a server, of course, we're talking about Node.js, because we need to run Angular on the server, and Angular is JavaScript when it's compiled from TypeScript. So of course we need something to run JavaScript on the server, and the only solution towards that is Node.js. However, if you want to use a different technology, there are wrappers that call Node.js in the background. So you can use .NET Core, Spring Boot, PHP, whatever, and just call Node.js from there so it renders our Angular application. So now let's set up such a Node.js server together. Here's the code, but I will hide it so we can develop it together. Where we need to start is our server TS. I just created it. It doesn't matter what name it has. We just need a TS file we can just run with Node.js. And I already did some imports for you. And the first thing to do is we just create an Express app. So Express is that framework or that library for creating web servers with Node.js. The next thing is we need some imports, references. The first reference is to our folder with the name of dist and SSR playground, where our client-side application resides. And the second is a reference or an import to our app server module ngFactory. That is our compiled server application, right? Good. And what we also need to at least run is that we listen on some specific port. We do it like that. So now we have a running server that does nothing. What we need to do now is we register a new so-called view engine with Express. A view engine is just a simple function that tells Express how to render specific templates. So what templates should be rendered? Well, it's our index.html, and our Angular application should be rendered inside there. So we just register a new view engine for Express with that app engine command. We should give it a name. And then we can use that handy wrapper ngExpress engine that comes from ngUniversal above here. And what we provide that is the application that should be bootstrapped. And that is our app server module ngFactory. Now that we set up we just set up a view engine for Express. And of course, a view engine can exist, but we need to use it. So that's the command app set view engine. And we put in the name HTML here so that Express uses that engine. The next part is also very simple, app set views, and we tell Express, oh, that doesn't work, app set views, and we tell Express where our views reside, and that is the dist folder, right? Our views are like our index HTML, nothing more. So now that we've set up everything, what is missing in an Express application? Tell me. Of course, a route. Because just by existing an Express application does like nothing, so we need to define some routes. And we need two different routes because our server has two main duties. The first is the easy part. We just serve out all our dist folder files statically. So for all files that exist, we just bring them to the client as a web server. And the second part is a bit more complicated, but it looks very easy. What we do is, whenever the route for the static files didn't match, it takes over to the next route, and then it renders our index.html file, and the rest is happening in the background. So we registered our view engine, we registered where like the templates reside, and that thing renders our index.html, brings up the Angular application, and just puts it into the app root host element. That's it. And you might not believe it, but that's the complete code for server-side rendering. It's so easy. So let's just try that out. For the sake of simplicity, I will just use tsnode to run that thing. Of course, in a real-world application, you would use like a Webpack build for that. But for now, for the demo purposes, I think tsnode is okay. And the application runs, and we can take a look at that at port 4000. And see there, our application works. And when I refresh, it's not flickering. And when I take a look at the source code, we can see that we have pre-rendered HTML here. And that is very, very good. It works just like a charm with a few lines of code. That is server-side rendering. Good. And now let's take a look at the first meaningful paint. It's the exact same application, it's the same circumstances, and the first meaningful paint went from 2.7 seconds to 1.1. So we saved like 1.6 seconds just by enabling server-side rendering. And that is very, very cool. So now let's recap what happens there. Whenever a user requests our page, the whole Angular application is being bootstrapped, rendered, and afterwards destroyed on the server for every single request. When you have a rather static site, or you have like static pages in your application, like the login form, the legal notice, the contact form, whatever. Of course, you don't want to do this every time a user requests that page, because that takes work at runtime. So what we can do else is called static pre-rendering. The idea of that is that we do all the stuff at build time. So we know the list of our routes, and instead of doing all this at runtime, we just call our build server and say, okay, bootstrap our Angular application, please, and then save the resulting HTML as a static index.html file to the file system. And then later on, when the user requests the page, they just get the pre-generated index.html file from that specific directory. So instead of calling everything at runtime, we just do it at build time. The main advantage of that is that it takes less computing time, less computing work at runtime, so that's very good. However, on the downside, we can't render any dynamic content because it has to be known at build time, and the same is with a list of routes. So when you have like dynamically generated routes that come from the database or anything else, you can't really render them at build time because you don't know them yet. So I'd personally go for a hybrid approach. So instead of using only one technology, just combine them and use pre-rendering for all the really static content like login form, legal notice, contact form, and then do the dynamic server-side rendering for the rest of your application. But only for the parts that are visible from the outside. So you don't need to do server-side rendering for like your admin area, because when the user has already engaged with your page, of course they have already downloaded all the bundles. Let's take a look at how that works. The main idea is that we take a list of routes and just transform it to almost the same thing, but in the file system. So whenever a user requests item book, they get the folder item, the folder book, and the index HTML within there. That's the idea. The main function to achieve that is called render module factory. That comes from Angular Platform Server. And what the render module factory function does, it just returns the resulting HTML for a route. So it takes like our function, it takes a document to be rendered, which is our index HTML in most cases, and it takes the URL to be rendered. And it just returns the generated HTML as a promise. So we can now use this and assemble everything together. First, we need, of course, some imports and the references to all those files. We already know that. The most important part is down here. That is a list of routes. So we need to define the list of routes statically, or at least obtain them from a database or from somewhere else. We need that list. And once we have it, we can iterate over there and run the render module factory function for each of those routes. So you can see the for each loop. We run render module factory, and then we save the resulting HTML to some files. So I prepared all that. You can see it right here in the pre-rendered TS file. List of routes for each render module factory. Nothing more than that. Okay, then we just run it. TS nodes, pre-render. That is really fast. And then after that, in our client-side dist folder, we've got those folders, item with all the subfolders. And let's take a look at that index.html file. We've got all the pre-rendered HTML in here. So we can just serve this folder statically without any Angular involved anymore, or like Node.js involved anymore. That is really cool. Good. And that's it. I showed you some strategies on how to do server-side rendering and pre-rendering with Angular. So, of course, you can take a real browser, but it always involves an external service. And then what you can do next is like the dynamic server-side rendering on every request. And the third part, which is also important, is a static pre-rendering where you do everything at build time. And you might have seen that SSR is really important for the search engine optimization and user experience aspect of your application, because it takes like 3 seconds to just load such an application on a mobile phone, and you can dramatically reduce this time by enabling server-side rendering. And the most great part about it is that it's really, really not hard, because the tooling around Angular evolved so greatly that we can just use server-side rendering out of the box, and it just works, as you might have seen. So that's that. You can find all the demos on GitHub, of course. You can play around with it, and please give it a try. You will get the slides afterwards, so I think you don't need to take a photo of that, but you can, of course. And before leaving you to the lunch break, let's tune in for the next talk. So make sure you be here early for Anjana Vakil with our talk about JavaScript recursion and iteration. So thank you for being here. Thanks for joining my talk. You can follow me on Twitter if you want, and thank you.